Hello, in this video we will be talking about hemostasis. Hemostasis is a process which causes bleeding to stop. It is the first stage of wound healing and includes three major steps: the vascular phase, the platelet phase, and the coagulation phase.
The vascular phase is the first step of hemostasis. When the wall of a blood vessel is cut, a vascular spasm is triggered in the smooth muscle fibers of the blood vessel walls. This contraction, or spasm, decreases the diameter of the blood vessel at the site of the injury, thus slowing or stopping the blood loss through the injured blood vessel wall. This vascular spasm lasts about 30 minutes and exposes the basement membrane to the bloodstream. While this phase is happening, the endothelial cells in the blood vessel walls are also releasing hormones called endothelins. These peptide hormones stimulate smooth muscle contraction and promote vascular spasms while also stimulating the division of endothelial cells, smooth muscle cells, and fibroblasts to accelerate repair to the injured area. Another change that occurs is that the endothelial plasma membranes become sticky, which allow for the attachment of the platelets in the next phase. The platelet phase is the second step of hemostasis. The attachment of platelets to sticky endothelial surfaces to the basement membrane starts this phase. This attachment is called platelet adhesion. As more platelets join together through platelet aggregation, a platelet plug is formed which closes the cut in the blood vessel, if the damage isn't too severe. This begins 15 seconds after the injury occurs. While platelets arrive, they begin to release ADP, thromboxane, platelet-driven growth factor, and calcium ions. This positive feedback loop is controlled and restricted by prostacyclin, plasma membranes, and the blood clot itself, which isolates the platelet plug from blood circulation.
30 seconds after the injury takes place, the coagulation phase, or blood clotting, begins. There are several important factors that are vital to the clotting process, and these are known as clotting factors, or procoagulants. Most of the clotting factors are enzymes that take place in a cascade, which enables fibrinogen to become fibrin and allows for a clot to form. There are three important pathways that are involved in the coagulation phase. The first is an extrinsic pathway, which combines factor 3, or tissue factor, with calcium to trigger factor 10 of the common pathway. Another pathway is the longer intrinsic pathway, which typically starts with factor 7 and combines with PF3 to continue its cascade and also lead to the activation of factor 10 of the common pathway. Lastly, the common pathway begins when factor X is activated and through multiple proenzymes, fibrinogen, which is a soluble protein, is converted to fibrin, an insoluble protein. Fibrin is then used to trap platelets and form the blood clot. These pathways communicate through feedback cycles to either stop or accelerate the clotting process. As the healing process continues, the clot must then be destroyed. Clot retraction is the shrinkage of the blood clot over a number of days, and it occurs due to the contraction of the fibrin mesh. As the clot retracts, it pulls the edges of the vessel closer together. The clot then begins to dissolve through a process called fibrinolysis. The activation of plasminogen produces plasmin, which begins digesting the fibrin strands and gradually destroying the clot.
Thank you for watching this video. We hope you enjoyed. Our names are
Tiana,
Kate,
And Arisbeth.
Please subscribe below.